An interactive workbook for Stoichiometry, High School Edition, written by Alexis Kilpatrick and Justin Lambert. What is stoichiometry? There are two types of stoichiometry. Composition stoichiometry deals with the mass relationships of elements and compounds. Reaction stoichiometry involves the mass relationships between reactants and products in a chemical reaction. This is what this workbook focuses on. All stoichiometry reactions have to start with a balanced equation which provides the numbers of moles for reactants and products. Mole ratio. A mole ratio is a conversion factor that relates the amounts in moles of any two substances involved in a chemical reaction. A mole ratio is needed for every stoichiometry reaction problem. The mole ratio is found in the balanced chemical equation. An example of mole ratio. So for this equation, you have 2 moles for every 4 moles and you have 2 moles for every 3 moles. And then you have 4 moles for every 3 moles. And then you also have the reverse. So you have 4 moles for every 2 moles. You have 3 moles for every 2 moles. And you have 3 moles for every 4 moles. Mole-to-mole conversions. In stoichiometry, we are asked to calculate the amount of moles in one substance that will be produced from the given amount in moles of another substance. This is done by the following conversion. The amount of given substance in moles yields the amount of unknown substance in moles. An example of mole-to-mole ratio. If you have 20 moles, and you want to find how many moles of lithium hydroxide, you use the mole ratio. So for lithium hydroxide, you have 2 moles, and for carbon dioxide, you have 1 mole. So you have to make sure they cancel, and you have 1 mole of CO2 and 2 moles of lithium hydroxide. Then your moles cancel out, and you're left with 20 times 2 divided by 1, which equals 40. So you have 40 moles of lithium hydroxide. Mole to gram. In stoichiometry, we are asked to calculate the mass of a substance that will be produced from a given amount in moles of another substance. This is done by the following conversions. You have the amount of given substance in moles, the amount of unknown substances in moles, and the mass of the unknown substance in grams. An example of this is if you have 3 moles of water and you want the grams of carbon dioxide. So you use the mole ratio. So you have 6 moles of CO2 and 6 moles of H2O. And then you need to use the molar mass in order to find the grams. So you take the molar mass of CO2, which is 44.01 grams, and put it over 1 mole. So your moles cancel with moles and your moles cancel with moles. And you are left with 3.00 times 6 times 44.01 grams divided by 6, which is 132 grams of CO2. Gram to mole. In stoichiometry, we are asked to calculate the amount of moles in one substance that will be produced from a given mass in grams of another substance. This is done by the following conversion: the mass of given substance in grams, the amount of given substance in moles, and the amount of unknown substance in moles. An example of gram to mole is where you have 824 grams and you want to find how many moles. So you take the grams and you convert it into moles. So you use the molar mass. The molar mass of this is 17.04 grams. And you put that under 1 mole. And then you use the mole ratio. So you have 4 moles of this and 4 moles of that. So your grams cancel with your grams and your moles cancel with your moles. So you're left with 824 times 4 over 17.04 times 4, which is 48.4 moles. Gram to gram. In stoichiometry, we are asked to calculate the amount in moles of a substance from its mass in grams of another substance. This is done by the following conversion: the mass of the given substance in grams, the amount of given substances in moles, the amount of unknown substance in moles, and the mass of the unknown substance in grams. An example of gram to gram is when you have 30 grams and you have to convert the grams into moles. So you have 1 mole over the molar mass, which is 20.01, and then you take the mole ratio. So here you have 2 moles and you put that under what you want to find, which is this, and it has 1 mole. Actually, it's this, 1 mole, that's enough too. And then you have to take the moles and convert it back into grams. So you do this by using the molar mass, which is 156.71 grams, and you put that over 1 mole. So your grams cancel with your grams, your moles cancel with your moles, and your moles cancel with your moles again. So you're left with 30 times 156.71 over 20.01 times 2. And this equals 117.5 grams Limiting reactants. The limiting reactant is the reactant that limits the amount of the other reactant that can combine and the amount of product that can form in a chemical reaction. In other words, it's the reactant that you can run out of first. When doing a reaction, there is a very large chance that you will not have the exact amount of each reactant. An example of how to find your limiting reactant. So you are giving two amounts. So you have 6 and 4.5. So you take the 6.0 moles and you do a mole to mole ratio with either this one or this one. And you can pick whichever one you want. For me, I'm going to pick this one. So you do a mole to mole ratio. So you have HF, which has 4 moles. And this has 1. And your moles cancel, and you're left with 6 over 4, which equals 1.5 moles. And then you basically do the same thing, but this time you do it with 4.5. So instead of using this, actually you're still using this, but instead of using this, you're using this. So you have one mole and 1 mole, which equals 4.5 moles. So what you do is you look at these two numbers, and the number that's the smallest is from your limiting reactant. So your limiting reactant would be 6.0 moles produced from a given amount of reactant. The actual yield is the measured amount of product contained from a reaction. How theoretical and actual yields apply to percentage yields. The percentage yield is the ratio of the actual yield to the theoretical yield multiplied by 100. This is shown by the following equation. So percentage yield is the actual yield over the theoretical yield times 100. An example of how theoretical and actual yields apply to percentage yields. So in this case, you have 36.8 grams of glucose, or not glucose. And you have to convert this into moles, so it's 1 mole over the molar mass. And then you do your mole ratio, which is 1 mole over 1 mole. And then you change these moles back into grams. So to do that, you use the molar mass again. over 1 mole. And you get 53.0 grams. And this is your theoretical yield. Then you take this yield and put it into the equation I showed you on the other page. So percentage yield equals the actual, which we were told was 38.8 grams, and you take your theoretical, which we got to be 53.0, and you multiply that by 100. And that ends up being 73.2%. And that is your percentage yield. So that concludes this chapter on stoichiometry, and I hope that you have refreshed your minds and learned hopefully more. Thank you. The end.